So one question for Mike was, what is your workflow, Mike, for coding with agents, multiple terminals and LLMs, or using like smaller tasks, Ralph loops, etc.? And then somebody else just to tack onto that will I'll also ask. You can answer these in whatever order you want. To give an example of the types of API changes you had to make. So those are the two questions that have come in so far. Is like, what's your procedure now for coding with agents, and can you give an example of the API changes you had to make?
Both are great questions, not because they are targeted at me, of course, but
Both are wonderful questions because now I get to answer them.
so for the first one, I'd say a mixture of, like, first of all, I run Ralph loops in two ways. I run it in the forward mode and in the backward mode. What forward mode means going from specs to code. What backward modes mean, it's going from code to specs. I feel like maintaining spec alignment is fundamental when you want to do a lot of autonomous coding, and specs tends to diverge because I'm gonna interchangeably use specs and implementation plans. They're fundamentally two aspects of the same thing. As the spec sort of describes the the feature you're working on, and the implementation plan is a detailed breakdown of how you're gonna proceed to implement that. As you iterate on your project, it will evolve and your specs will become outdated. Or you're going to work in a new project that doesn't have specs at all because it was built in 100 years ago when coding agents were not the reality. And Ralph works really really well also from going from code to specs. So I many times completely erase the specs in my project, and I tell my loop, hey, go file by file, feature by feature, and produce me an updated version of the specs that are aligned to code. And I do that constantly. Like, sometimes I just realize I have too many specs, they got disaligned, trash them all, and restart. So I do a lot of autonomous coding this way, but I also do a lot of human directed coding, especially when I'm starting to work on a new feature. For example, I don't know, I have a gRPC server, I want to build an HTTP API on top of it. The first two or three endpoints I direct it manually because I want to see the structure of the code that it generates. I want to see where files are placed, how it's gonna chunk the the code into good organization, the test practices, and so on and so forth. Once I'm sure that the direction is right, then I'm asking it to generate a full spec and run the Ralph thing. And it happened that I was running Ralph overnight. It happened that I had to trash all the code, regardless of if I was running it overnight or not. I feel like the productivity gain starts when you mix and match, and you start to realize when it's useful to run in autonomous mode versus where it's useful to run in human directed mode. And like any tool, you will have to gain a level of familiarity and intuition with it that is very hard to transfer and explain. Just like I could explain what TypeScript is, all of the ways of creating types, but then when would you use you know a, a conditional type? Where would you use a match type? It's all about the experience that you gain over time, and the intuition that develops in you of, like, yeah, this is a best good fit for this kind of problem, and it's really a sense. So that kind of broadly answered the first question. The second one, I can give a very specific example. So to back the context a little bit, Effect Cluster is a distributed runtime inspired by Erlang's Beam, and fundamentally it's an actor system that you can run distributedly, where you have entities that communicate via messages, and those messages can be persistent. When you have a persistent message, you're gonna have what we call at least once delivery, which means the message will be delivered for sure, but it might be delivered multiple times. And that's really the basics of how you do reliable distributed systems. On top of that, we've built a workflow engine. Workflows are similar to what you find now in Temporal, Cloudflare, Vercel has workflow implementations, and so on and so forth. Fundamentally, workflows are durable functions. What a durable function means is a function that is invoked up until the point that it completes. If it fails, it's going to be invoked again and again and again and again and again. With cluster, we use the persistent messaging between entities as the function invocation. So the API that I've developed initially was entity based. I had, for example, a user's entity, and I could have multiple workflows within the same entity. And that's very nice because it gives you logical grouping. Create user, delete user, and so on and so forth all falls under the users category. And entities are restricted to process one message at a time. That means one workflow is not allowed to call another workflow on the same entity. Otherwise, it would deadlock because you would have one message that is given to invoke the first function, which invokes itself with a second message, but the second message would not proceed until the first one finished. But for the first one to finish, the second one has to go through. That's classical deadlock scenario. For a human, that's not a hard rule to understand. You consider entities as grouping of functions. Each function should be independent, and you call one at a time. Well, agents did not have a good time with that. They would consider entities in the same way that classes are, workflows as methods, and they would slice up the logic into smaller and smaller workflows and keep calling
I
each
see.
other. What I had to do is model the workflows in a way where there's no way that you can have two workflows on the same entity. You have a workflow definition, you define them in a similar way to a function, and there's no construct to have two workflows on the same entity so that the model would not go there. And now the model can perfectly write workflow code using my library, which is, by the way, non-documented, and so on and so forth. The way I'm using it is by cloning the repository locally, and the same tricks that we use with effect. But this is one of the APIs where a human would have liked the first one better. An agent required more engineering around eliminating the potential problems. Could I have done it with linting rules and other stuff? Probably yes. But if API can be solved, it's better than type checking, it's better than LSPs, it's better than manual rules. I feel like there's a chain where if the API is great, for models, they're gonna perform 100%. If the API is so-so, but you have linting rules, it performs 90%. If you cannot have linting rules, but you have general markdowns explaining it, is like 50%, and the optimize is as high as higher you go in this logical chain. That's one example in Rust. In TypeScript, a similar thing we are doing with services, but that's
Somebody
that's a
said
different thing.
somebody said we should have Mike here more often. I don't know how to take that. Carnaloot. I don't know how to take that.
Well,
Um,
I would like to be here more often, and unfortunately, in the past few months, I've been concentrating on something else, which is also very important for the company to run. So, but now I'm back, so hopefully I'll be.
well, we have some more questions, but I do want to comment. I think that it's very interesting. Like the more guardrails that the API provides, the better the L. It's again, it goes back to that kind of like back pressure type
Mm.
thing. If the LLM can't go down a path, if you make it impossible to go down a path, then you're gonna have a better time with your agent.
It's basically
Uh,
shaping your API in a way that it's impossible to code them. You are basically writing API in a way that it's impossible to write code that performs bad patterns.
People are trying to make me feel better, but it's not working. We love you, Max. Mike just has more specific problems that are cooler to learn. He brings the best out in you, Max. I think that's what Carnaloo meant. Yeah, sure, guys. Whatever. See if I show up next week. Uh,
But
but
if
if
we
we
had to
had to
pick,
pick, um,
I'm just lucky that I work on probably like I like to detach myself from the current point in time and try to work 6-12 months ahead. So I'm lucky enough to be able to focus on other stuff. And like if I had to focus on shipping effect v4, I would have not experimented so much on the AI side. So I feel like everybody has its own, like if effect 4 exists, it's thanks to the team, it's not thanks to me. So I feel like we should all, and just more interesting because I'm doing other problems, but they're equally important to the rest.
there was one question about whether or not test-driven development helps in this particular problem domain, like asking LLMs to write tests and then asking it to implement a compliant change. I don't know. I've had mixed experience with that because I feel like the LLM writes tests to conform to the like code it's going to write. Maybe if you write the tests first, it's better. But I don't know what your opinion of test driven development with an LLM is. I feel like tests, in my opinion, are better for like the back pressure aspects I was talking about before. But curious what you guys think.
That's an interesting conundrum. I've always been very against test driven development for humans, and I think the same reason it's bad for humans is the reason why it's bad for agents. The issue is testing everything up front is impossible, and using the tests as the specification is not a greatly descriptive way. Plus, the model is going to implement a lot of mocked APIs and a lot of to-dos, and then it's going to forget to clean up the to-dos and get into a state where it's odd. I feel like what models really allows is very easy automation. For example, the way I'm testing Cluster, I'm spinning up Docker containers for multiple nodes, etcd, Postgres, and so on and so forth, and I'm letting tests run on real live infrastructure. For internal projects, we have tests running on physical servers where we are at the point where we have provisioned the full operating system of a server automatically, and we can basically test everything from operating system provisioning up to our services running on top of the servers automatically. And when we run Ralph loops and when we run testing, all of this is happening within seconds. Those are much more important tests for back pressure, as Maxwell described, and to really ensure that the behavior is what you expect versus just imposing a rule on what should be coded first. Sometimes the agent will prefer to write the test first, sometimes will prefer to write the code first. I don't think you should impose either of the two. What you should impose is great coverage and extremely well designed back pressure. At least that's my intuition. But that also may depend on the language, because maybe other languages have better infrastructure. Like I'm thinking more esoteric languages like Lean, where you can do proofs and so on and so forth. It might be a slightly different thing there, but obviously you're not going to use those languages to build a boring old CRUD application. So I feel like for the problems we all deal with, this is kind of truth. But if you generalize more, it could be slightly gray area.
They're groveling now, Mattia. They don't want us to leave them.